And I don't care if it's raining, it's just going. Okay, nothing personal. You probably won't even watch this.
Oh, it's
Anyway.
probably won't.
Okay, so here's how today is going to play out. So what you're going to do is, you're going to, out of all of these solutions, you're going to use them in different places. So on this first part, okay, you're going to mix, like for example, magnesium nitrate and sodium hydroxide, okay, or potassium hydroxide, okay? And the Chem 1 version of this is that it's a double displacement reaction. You get magnesium hydroxide and potassium nitrate. You balance it. Oh, I need 2 hydroxides. I put a 2 there. I put a 2 there. Boom, it's balanced. There's the Chem 1 version of this double displacement reaction. You also need to do the net ionic. So to do the net ionic, you have to figure out which one of these is insoluble. If you're not sure, this is where Ksp and Ka are similar. If you go through the back of the book and you try and find the Ksp value for potassium nitrate, you're not going to be able to find one. Why? It's soluble, just like you can't find a Ka value for hydrochloric acid. It's not there because of the fact that hydrochloric acid is a strong acid. Therefore, there's no Ka value. Potassium nitrate is soluble. Therefore, you're not going to find a Ksp value for it. Now, can you find one for magnesium hydroxide? All day long, okay? Because that's insoluble. So, you're going to have 2 sets of reactions. The Chem 1 reaction, and then you're going to have the net ionic, which is only going to show the formation of the precipitate. So for each of those 3 reactions, or 3 reactions that you're going to mix together, you should have 2 equations, okay? The normal Chem 1 version of it, and then the net ionic. Make sure the net ionic is balanced in terms of charge and number of particles. And if it's a charged particle, make sure you put the charge on it. Now, the next thing that you want to do is you want to calculate the QSP. Remember, QSP and KSP mathematically are calculated the same way. The only difference is that K only exists at equilibrium. Q is going to tell you which direction it's going to go based upon the concentrations after they are mixed. So here's what you're going to do. You're going to mix 4 milliliters of, in this case, magnesium nitrate and your potassium hydroxide. This is what I would do, okay? Because it's just going to equal volumes. You could just pour in like 4 milliliters into a test tube, okay? And like make a mark, take a Sharpie or something to make a mark. And then make that same mark on the other one. And then that way it's like 4 milliliters, as long as it's just the same volume. Then the whole key to this is then you're going to mix these things together. Now, once you mix them together, so you should hopefully see a precipitate form. That's the whole point of this, okay? Is that, hey, do you see a precipitate? So on the chart, okay, on the chart, so here's what you're going to do. You're going to have, and if you want to see what a nice chart can look like, look at Bethany's.
Good job.
So you're going to have the 3 different reactions, so you could call this reaction 1, 2, and 3. Boom. Okay? And so I tell you exactly what you want. So you want to have a chart that says, hey, what were the conditions after they mixed? Was it clear? Was it a precipitate? Was it a lot of precipitate? Was it a little precipitate? Was there a gray precipitate? Was it a white precipitate? Was it a red precipitate? Okay? You don't have to write a 5-paragraph essay. Just tell me, hey, this is what we saw. But that's after they were mixed, because obviously they're all going to be soluble beforehand. Okay? So you're going to have and then this is where you want to do this in a test tube, and then you want to measure the pH before you begin to add the hydrochloric acid to it. Okay, cool, whatever that is. So then, you're going to add the hydrochloric acid until the solution becomes clear. Okay, so you're going to have your initial pH. Then you're going to add, after you've mixed these together, you're going to begin to add hydrochloric acid. Let me give you a hint. Again, do not focus on the precipitate. Focus on what is happening in the solution up above. So if you look at the first one, that's that one with that magnesium hydroxide. The most common misconception everybody has, like, oh, it's all a precipitate. There's no magnesium or hydroxide up above. Yes, there is. It's just a very, very small amount of it. So when you add that hydrochloric acid, are you going to worry about what the chlorine's going to do? No, because it's not common. It's not common with the hydroxide. It's not common with the magnesium. And the chloride is just happy. It's off by itself. It's just going to chill out and go, hey, you guys knocked yourselves out. You do you. I'm just going to be cool. Okay, because that's just how I am. I'm just that cool. But what's the hydroxide going to hook up with? The OH, and you're going to make. So what's going to happen to the concentration of the hydroxide ions? It's going to go down. But Mother Nature doesn't like that, so what's Mother Nature going to do?
On a heist.
It's going to go to the bank of the precipitate of magnesium hydroxide, and it's going to start to make withdrawals. Now, can it just pull out of that precipitate of MgOH2, can it just pull out the hydroxides? No, it's part and parcel, okay? So that's why it's going to dissolve. So you're going to get magnesium ions going into the solution, and you're getting hydroxide ions going into the solution. Then you're going to record the pH after it becomes clear, okay? See what happens with that. And then you're going to have the number of drops of hydrochloric acid it's going to take. You should have a dropper bottle like this on your bottle that says 1 molar hydrochloric acid. This is what you use, okay? So, again, I want to be impressed. Do not make this look like a third grader drew it with a Crayola marker, okay, and a dull Crayola marker at that during an earthquake. No, okay, I want to be impressed. As you erase.
I made the lines too big. This is
Okay.
going to be a little
Now,
part of my reach.
part
Oh,
2.
no, you're good.
This gets a little bit dodgy. So on this one, you're going to mix 1 milliliter of zinc nitrate and 1 milliliter of sodium carbonate in a test tube. That you might use a graduated cylinder for. If you're going to use a graduated cylinder, make sure that you rinse that graduated cylinder with the ionized water in between. Otherwise, those ions are still going to be left in there from the previous reaction. Okay? So if you're going to use a graduated cylinder, make sure that you rinse it in between. Then you're going to do that in 2 different test tubes. So then you're going to run that into the centrifuge. Okay? Boom, spin it up, let it run for maybe a minute. You should see that the precipitate settles to the bottom and the solution comes up on top. Because all you're doing is creating a very, very strong gravitational field. So then you can take a little plastic, the squeezy pipette, and you're going to try and remove the water, okay, or the solution that's up above. You obviously can't get all of it, but you should be able to get the vast majority of it, okay? Make sure that you leave the precipitate. So once that's done, you're going to add hydrochloric acid to one of them, and then you're going to add water to the other one. And you're going to keep track, okay? So you're going to add that stuff until one of them kind of dissolves. And then it varies kind of upon the size of the dropper and things like that, but generally it's about 20 to 30 drops. And until a noticeable difference is observed. Keep track of which is your hydrochloric acid and keep track of which one is the water. If got some questions to answer on that. Now, here's part 3. You're going to add 5 drops of 1 molar sodium hydroxide. That is going to come from a dropper bottle on your table, okay? This is not the potassium hydroxide that you mixed up before. This is 1 molar sodium hydroxide that is going to be on the table, okay? And you're going to add 5 drops of the 1 molar magnesium nitrate. This is not the magnesium nitrate that you mixed up before. This is the 1 molar stuff, which again should be in a tray on your table. So, then you're going to add about 30 drops of water, okay? And then, hey, did it dissolve after you added 30 drops? Just look at that. Then you're going to centrifuge it. Now, here's what you have to be careful when you do this centrifuge. You're only going to have 1 test tube. You can't run a centrifuge with just 1 test tube. So either find a centrifuge buddy to do this with, or take another test tube, fill it up as a water blank, so that way you have this thing balanced, okay? Just don't run the centrifuge with 1, because then it makes a god-awful racket, and everybody's going to look at you and go, you didn't listen to the instructions, did you? Because there's no way to hide this. Like, no, it's balanced. No, it's not, okay? Like, this thing is going to bounce all over the place, right? So, I'm just telling you. Now, here's the sketchy part. When you get to number 3 on the back side, line 3, it says, gently add a small amount of solid magnesium chloride that is equivalent to the end of a match head. Okay? Well, it was the best descriptor that I could get.
I think I could think of better.
Well, I used to have like a half of a garden pea, and that didn't go well. The kids going, what does half of a garden pea look like? It's like, oh my God. Okay, so this is actually the second version of this description. Okay, I used to have half a garden pea. The kids didn't like that, so then they said, what about a match head? Okay, I can live with that. All right? So don't complain. This is what your fellow classmates in previous years suggested. Okay? I was organic and had half of the garden pea. They said, no, fire! And so that's why it's a half a matchup. So now, here's what's supposed to happen. Okay? I hate to bias you, and about 90% of the time, it works like it should. But sometimes it doesn't. So here's the test tube, and you've got this precipitate of magnesium hydroxide down here. And to this water up above, you're going to add some magnesium chloride, okay, which is soluble because it's a chloride, and all chlorides are soluble except for silver and lead. So here's the idea. When this hits the water and it dissolves, what's going to happen to the concentration of the magnesium ions? It's going to go up. Okay, that's like someone injecting a bunch of freshmen into my room, God forbid. Am I going to be in equilibrium? No. What am I going to tell the freshmen to do? Sit down and shut up. Okay? So basically, here's what should happen. Is that once you add that magnesium chloride, you're increasing the concentration of the magnesium ions. Mother Nature doesn't like that. So how can Mother Nature get rid of the magnesium ions? Turn it into a precipitate. So what you should see happening is that you should see some more precipitate form. And like I said,
I liked that impression. That was good. That was very accurate.
years of practice. Okay. Okay. You asked about that. So, like I said, about 90% of the time, you see a noticeable layer of precipitate form. For some reason, about 10% of the time you don't. So, if you don't, pretend that you did, which I know is totally non-scientific, but the math works. Okay? Then you have a bunch of questions to answer 1 through 11. Okay? Now, let's talk about what I want on question number 2. On question number 2 it says, make a sketch showing the system before the hydrochloric acid was added and after, including the solution portion. Make a second sketch showing the impact of the hydrochloric acid. So all I'm looking for on this is that you're going to say, this is your chance to be a sparkling artist. Okay? Before. So down here, and this is talking about the one with the first 3 reactions. You can pick one. I picked magnesium hydroxide. So you've got chunky magnesium hydroxide down here. You have a certain number of magnesium ions, and you have a certain number of hydroxide ions, right? So that's before you add the hydrochloric acid. So then, what I'm looking for is this is after you add the hydrochloric acid. So this is, now it's another snapshot after the hydrochloric acid has been added. So what do you think I'm looking for in terms of the amount of magnesium hydroxide precipitate? It's less, right? Okay. So what do you think is going to happen to the concentration of my magnesium ions?
Stay the same.
Because this is dissolving, right?
Yeah.
So your magnesium ion concentration is actually going to go up because it's dissolving, right? But what's the hydronium ion and the hydroxide ion going to create? So that's what you want to show, okay? It doesn't have to quantify it. Well, you're not going to draw 6.02 times 10 to the 23rd water molecules. Good luck with that.
If I do, do I get extra credit?
I would have to count it, and no, wouldn't be worth the effort. No thanks. So that's basically, you don't have to like make this in great detail, but basically all I'm getting you to do, because the AP exam is shifting more and more towards these particle diagrams. And so I just want you to be able to recognize them and go, hey, this is what's going on. The rest of them are pretty straightforward. And again, same format, answers on the left, work on the right. So, all right, I'm done. You're on your own. Due tomorrow. The lab itself is going to take you maybe like 20 minutes to do.
3 hours?
Kevin, did you stop the camera?
You never know.
Let's go with no.
Yes.